Hey guys, welcome back to my YouTube channel. This is Vivek. I'm studying in Information Science and Engineering, 6th Sri Venkateshwara College of Engineering, Bangalore. So here, today let's see a subject called software testing. And a topic in a subject software testing is decomposition based, call graph based and a path based integration. So let's see what are all the contents in a software testing. So the contents are decomposition based integration, call graph based and a path based integration. So decomposition based integration. So this is the basic SATM functional decomposition tree. We can dispense with a Big Bang approach most easily in this view of integration. All the units are compiled together and tested at once. The drawback to this that when a failure is observed, there are a fluke plus T help isolate the location of the fault. Top-down integration. So, top-down integration. What is top-down integration? Top-down integration begins with the main program, that means the root of the tree. Any lower level unit that is called by the main program appears as a stub, where stubs are piece of throwaway code that emulate called a unit. If we perform top-down integration testing from a SATM system, the first step would be to develop stubs for all units called the main program. Watch card slot, control card roller, screen driver, validate card, validate pin, manage transaction. So procedure get pin for a pan expected pin stub. If pan is equals to 1123, then pin is equals to 8876. If pan is equals to 1234, then pin is equals to 8765. If pan is equals to 8764, then pin is equals to 1253. And procedure key sensor key hit stub. Data keystrokes stack of 888 cancel. Key hit is equals to pop keystrokes end. Once all the stubs from SATM main have been provided, we test the main program as if there was standalone unit. We could apply any of these appropriate function and structural techniques and look for the faults. Bottom-up integration. Bottom-up integration is a mirror image to the top-down order, with the difference that steps are replaced by driver modules that emulate units a next level up in a tree. In bottom-up integration, we start with the leaves of decomposition tree, so which is units like control door and dispense cache, and test them with the specially code drivers. There is probably less throwaway code in drivers than there is in a stubs. Recall we had one stub for each child node in decomposition tree. Most systems have a fairly high fan out most systems have fairly high fan out near to the leaf, so in bottom up integration order we won't have so many drivers. This is partially offset by the fact of the driver modules will be more complicated. And so the next one is sandwich integration. What is sandwich integration? Sandwich integration is a combination of top-down and bottom-up integration. If we think about it in terms of a decomposition tree, we are really just doing Big Bang integration on a subtree. So this is all about a sandwich integration. And so the next one is call graph based integration. So let's see what is all about call graph based integration. One of the drawbacks of decomposition based integration is that basis in the functional decomposition tree. So this is the drawback of the decomposition based integration. If we use the call graph instead, we mitigate the deficiency we also have in the direction of the behavioral testing. We are in the position to enjoy the investment we made in the discussion of a graph theory. Since the call graph is directed graph, why not use it the way you use program graphs? This leads us to two new approaches to integration testing we will refer to. And the first one integration testing is pairwise integration and the second one is neighborhood integration. So let's see what is about pairwise integration and neighborhood integration. So pairwise integration. The idea behind pairwise integration is to eliminate the stub or a driver development effort rather than develop stubs or drivers. Why not use the actual code at first? This sounds like a Big Bang integration, but we restrict a session to just a pair of units in the call graph. The end is the result. We have one integration test session for each edge in the call graph. So this is all about pairwise integration. So the next one is neighborhood integration. We can let the mathematics carry us still further by borrowing the notation of neighborhood from topology. This isn't too much of a stretch. Graph theory is branch of topology. We define the neighborhood of a node in a graph to be set of nodes that are one edge away from the given node. In directed graph, this means all immediate preceders nodes and all immediate successor nodes. The 11 neighbor nodes for the STM example based on a call graph. So this is a SATM neighborhoods nodes. We can easily compute the number of neighborhoods for all given call graph. There will be one neighborhood for each interior node plus one extra in case there are leaf nodes or connected directly to the root node, whereas an interior node has a non-zero in degree and a non-zero out degree. So this is all about integrations. So let's see what is integrations. Much of progress in the development of mathematics come from an elegant pattern. Have a clear idea of where you want to go and then define the concept that you take there. We do this there for path-based integration testing, but first we need to motivate the definitions. When a unit executes some path of source statement is traversed, suppose that there is a call to another unit along such a path. At the point, control is passed from calling unit to the called unit, where some other path of the source statement is traversed. The first guidance for paths. Points of quiescence are natural endpoints for an path. Our second guidelines also serves to distinguish integration from system testing. Our second guidelines is atomic system functions are upper limit for paths. We don't want paths to cross ASF boundaries. There are two possibilities: abandon a single entry, single exit precept, and a treat such as a call as exit followed by entry, or suppress the call statement because control eventually returns to the calling unit anyway. The suppression choice works well for unit testing, but it's antithetical to integration testing. Thank you. Please do watch and like, share and subscribe to my channel.